Hello everybody, welcome back to another video. In today's lesson, I'm going to show you how to balance chemical equations. This is the most simple way, and I'll be showing you four types of chemical equations you might encounter. The first one, let's take a look at this. Here we have C2H6O plus O2 equals CO2 plus H2O. This is the combustion. Simply by having CO2 and water, I know it's combustion. Okay, how do we balance this? Okay, for combustions, typically you start with carbon. In this case, you want to get the same type of coefficients on both sides, and so they would balance out. So, for example, you want the same number of carbons on this side, the same as this side. As you can see right now, we have two carbons here and one carbon here. You want the same number of hydrogens on this side. This is the reactant side, and this is the product side. Why do we want to do this? Very simple, because we want to follow the law of conservation of mass, which states that matter cannot be created or destroyed. It just changes. So let's begin. What I like to do in this one is start with carbon, and I like to go from the top down, or start with the one that's more complicated. So, for example, C2H6O is more complicated than O2. So I start with this one first. So we have carbons, we have two here, and over here we have each color, two here, we have one here. What can we do to change that? You will keep in mind that you cannot change subscripts. You can only change the coefficients. So you can only change the numbers right here in front of the formula. Why? Well, because let's say we had H2O. If I want to get two more oxygens, this would be wrong because that's a totally different formula. I believe that's hydrogen peroxide. And you know, hydrogen peroxide is it's not very good to drink. So what can I do to change this to a 2? Only using the coefficient. I can put a 2 here. Think about carbons and oxygen, hydrogen as number. For example, this is a 1, this is a 2, this is a 2, this is a 1. Think about it that way. That will help you out a little bit more. So 2 times 1, 2. 2 times 2, that is 4. And keep in mind this other oxygen over here. I like to write when you have a plus sign, write what you have. For example, if I have an oxygen here and have another oxygen here, I like to write this on top to remind me I have another oxygen here. So that's 4 plus 1, 5. Okay, now let's begin. With hydrogen, I have 6 here, I have 2 here. What can I do to hydrogen to get a 6? If this is a 2, I need a 3. That's 6. But remember, oxygen is here. So we had 4 oxygen here. 3 times 1 is 3. That is 7. And now this is balanced, this is balanced, this is balanced, this is balanced. The last thing we need to balance is this. But Ojo. That's a really bad ojo. Oh, forgot I had this right here. And let's do that. There we go. There we go. Sorry about that. Uh, oh, we have 2 oxygen here and 1 oxygen here. We want something to get to 7. Now, if we were to add a coefficient here, this will mess up our whole formula. So it's much easier to just add something to this lone pair to give us 7. And remember, we have 1 here and 2 here. So if you think about it this way, what do we need here to make this true? Correct. 3. And what's that going to do for us? Well, we each added 3 here. That's 6. 6 plus 1, 7. This is balanced. So the final answer is C2H6O plus 3O2 is 2CO2 plus 3H2O. And remember, never put a 1 in front of something that's blank. That is not correct. You might get points off if you do that in a test. Okay. Next formula. Let's do HCl plus NaOH gives us NaCl plus H2O. So for some of you might recognize this formula. This is an acid, the base. Acid and a base gives us water and salt. So just keep in mind as well that I am not writing the states of the chemical formula. For example, this is aqueous. This is aqueous. This is a solid. I believe that's aqueous as well. Yes, I think that's aqueous. Aqueous salt. Yes, that's aqueous. Just do that, and then this is liquid. Just keep in mind that I am not writing that here, but in future lessons, even in your classroom, you might need to put the state of the chemical formula. It could be gas, a solid, or liquid, or an aqueous solution. So let's begin. So we know that this is an acid and a base. Now, the easy trick I have for y'all is whenever there's an acid and a base, all you gotta do is look at the coefficients of the acid. For example, this one, we only have 1s. And for this one, we have 1s as well. So 1 is for the base. The subscript of the base goes to the coefficient of the acid. And the subscript of the acid goes to the coefficient of the base. That's 1, 1, And these two multiplied go to the coefficient of the water, 1. And you just switch the terms for this one and for this one. You get NaCl. But just to show you, let's do HCl, HCl. We have 1 hydrogen, we have 1 chlorine, we have 1 sodium, and 1 hydroxide. And let me show you something. Oh, typically, whenever you see a polyatomic ion or something that's combined, for example, here we have oxygen, hydrogen, hydroxide, I believe. Write it out as this. Don't, because if I were to do this, then I'll have 2 oxygen and 1 1 oxygen, and that would make it more complicated. So just write the whole polyatomic ion instead of writing it by itself. And we rearrange, and we have, for example, here, I like to do this as well. For water, we have 1 hydrogen, and we have 1 chlorine, 1 sodium, and 1 hydroxide. And you can tell this is balanced. Now let me show you another example. Mg H three plus H2O. Now again, the trick here is I know this is acid. I know this is the base. So what do? I take the subscript of the base, put it here, and I take the subscript of the acid and put it here. And you multiply these two and put it in front of the water. And this should be balanced. Now, just to show you that it's balanced, let's do hydrogen. I believe this is phosphate, magnesium, hydroxide. 1, 2, 4. Same thing over here. Hydrogen, phosphate, magnesium, and hydroxide. Okay, 2 times 3, 6. 2 times 1, because remember, you only look at this one as a whole. 2 times 1, that is 2. 3 times 1, that is 3. Magnesium. 3 times 2 is 6. So now we go this way. I like to break this into this. 6 times 1, 6. 6 times 1 is 6. We have 3 magnesium, and we have 2 phosphate. There you go. I just showed you that, proved you that that trick really does come in handy. So this is the final answer. I just wanted to show you how that trick can apply to acid and base. Okay, and then let me show you last example. FeS2 plus O2 is Fe2O3 plus SO2. I believe that is, yes, that's correct. Okay, so like again, I showed you, let's begin by figuring out how many elements that we have. We have iron, sulfur, and oxygen. You have to the left, you should have on the right. So we have one iron, two sulfide, and two oxygen. And over here we have two, remember, count the bottom ones. We have one sulfur, and we have 1, 2, 3, 5 oxygen. Here, what I like to do is start, like I said, with the top ones, or the ones that are more complicated to start. So for example, let's start with the top one. Here we have two over here, and we only have one over here. So we add 2 here. So we multiply 2 times 1, 2, 2 times 2 is 4. Let me switch this to a red. And we have, we still have 2 over here. So now this is balanced, this is balanced. The next one should be sulfur. We want to get to 4, so what do you do? Correct, multiply by 4. So that's 4. That's an 8 oxygen. We have 3 here. So we have a total of 11. So balanced, balanced, perfect. Now here comes the tricky part, and I want you to pay attention to this. So we have 11 oxygen, and they are combined of this one and this one. But we only have 2 oxygen, and there's no more oxygen over here. So it's just by itself. What can I do to get 11 over here? Now think back to fractions. What do we need to do? Have 1/4. What do I need to multiply with to just get the whole number? 4. You get 1. So the same concept applies here. What I'd like to do here is this. I know I need 11, but I only have 2. So what can I do? What I do is I add the total number that I need. In this case, it's 11 here. Leave it like that. Now, I want to get 11 by itself. What can I do to get 11 by itself? You multiply by a number, to get 11 by itself. In this case, we can add a 2 at the bottom. And 2 as a whole. Why a 2? Well, remember we have 2 down here. Correct? We have 2 here. We want 11. We want to cancel the 2. How can you cancel the 2? You multiply by 2. So let's do 2 here. And now what? Well, like I said, we multiply by 2. But again, do you have to multiply to the whole equation so this can work out? So we put 2 times everything. So 2 goes into this one, 2 goes into this one, 2 goes into this one, and 2 goes into this one. 2 times 2, 4. 2 times 11 over 2. Yes. That is 4 is 11. 2 times 1, 2. 2 times 4, 8. And as you can see here, we have 4. Get rid of this. Two. We have 4 FeS2 plus 11 O2 equal to 2 Fe2 O3 plus 8 SO2. This is your final answer. Now you want to double check. We have 4 here. 2 times 2 is 4. Just check. We have 4 times 2, that's 8 sulfur. 8 times 1 is 8. Check, check. We have 11 oxygen. We have 2 times 3 is 6. That is oxygen. Oh, wait, yeah. This is 22, because we have a 2 here. 6, this is 16. That is 22. And that's correct. So, whenever you have whenever you get like an odd number, like this one, and you have a lone pair, or you're trying to get rid of it, you need to find out the total number that you need. Find out how many do you have. For example, I have 2 here, put at the bottom, and multiply by the same number to get 11 by itself. But the same number needs to be multiplied for the whole equation. And that is the end of this video.